Hey student, welcome back. We are in Unit 3, More Derivative Rules. And today we're going to be talking about implicit differentiation, which is a very, very important topic and we'll continue to use throughout the course. Okay, so what does it mean? Well, normally when we're taking the derivative, we can take the derivative of the whole equation, d dx of y equals x squared, and this ends up being the y turns into dy dx, right? We know that, we've seen that. And the x squared will turn into 2x. Okay, now what happens if we flip this around? If we have x is equal to y squared? Well, we know that the derivative of x is just 1, which is true. Y squared, what's going to happen here is we're going to use the chain rule. We're going to think instead of y squared, this is something squared, which we had talked about before in another video. If we have a function within a function, we think of the inside as just something. So we have 2 times that something, which is y. And then we multiply by the derivative of y, which we just showed was dy dx. So this would be 1 is equal to 2y dy dx. Now, there is something that I want to comment on here because I do think that students sometimes get confused. Why don't we do something with x, something special with x? Why is it just 1? That's a good question, and we absolutely could. We could say, you know, when we're taking the derivative of y, we replace this blank up here in d dx with y. We do the exact same thing with x. So instead of the derivative being just 1, we could say it's dx over dx. We're using the same logic as the derivative of y, but just applying it to x. But the thing is dx over dx, anything over itself is just 1. So that's why we don't bother writing dx dx. And for you, you know, earlier on in calculus, that would have been confusing. Like, why are we writing this dx dx? But now it might help you sort of understand how to take derivatives of things that aren't x. Okay, so let's continue using this logic. So the derivative of y squared, bring down the 2 and multiply by dy dx. The derivative of x squared is just 2x. And we could multiply by dx dx, but really that is just 1. Okay, now we have almost the same thing, but we're taking the derivative with respect to t. So we do the same thing, 2y, but this time we don't have dy dx, we have dy dt. For x squared, we bring down the 2x. But now, because x is not the same as t, these are 2 different variables, we are going to have dx dt. Okay, and something that you have probably talked about or heard your teacher say in class is the variable y with respect to x, or defined with respect to x, or with respect to t. So that the way that I like to think about that is if we had a graph, you might have heard your teacher say, we're taking the derivative of y with respect to x, or x with respect to t. What I want you to think about graphically is whatever variable you're taking the derivative of, so y, goes on the y-axis or the vertical axis, and then whatever you're taking it with respect to goes on the x or horizontal axis. So in this case, dy dx, y would be your vertical variable and x would be your horizontal variable, but we could be taking the derivative of x with respect to t, and then x would be your vertical variable and t would be your horizontal variable. And that's why we would have dx dt. And with respect to means that you have some equation, let's say x of t, where t is the variable that defines x. So we could say t squared plus 3t. That would be x with respect to or in terms of t. Okay, so let's do some implicit differentiation problems. We want to find dy dx of y squared minus 2x plus y minus 6 equals 0. So we know the derivative of y squared is 2y dy dx, can't forget that, minus 2x minus 2 plus the derivative of y dy dx. 6 is 0 and 0 is 0. Okay, now we need to move some things around. We can add 2 to both sides. So we have 2 dy dx plus dy dx is equal to 2. And then in order to get dy dx by itself, this is something we're going to have to do a lot. We need to factor dy dx out. Dy dx, 2y plus 1 is equal to 2. And finally, we can divide by whatever's on the left side, 2y plus 1. So we have dy dx is equal to 2 over 2y plus 1. Okay, continuing. We want to find dy dx of 8xy minus sine y is equal to e to the x. So 8xy is a product rule problem. And I had said in the last video, we're going to start not writing this fully out. So if you're working on this on your own, you might still want to write it out. But for me, I'm just going to say, well, 8 times the derivative of x, which is 1, times y, we leave that alone, plus 8x times the derivative of y, which is dy dx. Minus the derivative of sine of y is cosine of y times dy dx. E to the x, as always, e to the x. Okay, so we need to move things around. I'll subtract 8y and factor out the dy dx all in one step. Dy dx, 8x minus cosine y is equal to e to the x minus 8y. And then we'll just divide. Divide by 8x minus cosine y is dy dx. E to the x minus 8y all over 8x minus cosine y. All right, another one. We are going to find the second derivative of 3x squared minus 6 square root of y plus 4x e to the y equals 0. This could be a lot of work. Let's see. So bring the 2 down. We have 6x. I'm going to rewrite this as minus 6y to the 1/2. We don't like the square root in calculus. So we'll bring down the 1/2. We have minus 3y to the negative 1/2 times dy dx plus another product rule problem. 4 derivative of x is 1, e to the y plus derivative of e to the y is e to the y dy dx equals 0. Okay, so we're going to work on factoring out our dy dx and getting everything else to the left side. So first of all, I'm going to subtract 6x and 4e to the y. And on the left, we're going to factor out a dy dx. And that would leave a minus 3y to the 1/2, negative 1/2, plus 4x e to the y in parentheses. And then we'll divide both sides by this. And you know what? I'm realizing this is a lot of work if we want to take the second derivative. So we might just not do that. 4x e to the y. Yeah, so if we take the second derivative, we can do it. We can do it. It'll just be a quotient rule problem. So d squared y dx is equal to HODY high, negative 3y to the negative 1/2 plus 4x e to the y minus, or times HODY high, d high, the derivative of the top, negative 6 minus 4e to the y dy dx minus HIDY ho, we leave the top alone, minus 4e to the y. And the derivative of the bottom is 3/2 y to the negative 3/2 dy dx plus, well, we got to do the product rule again here. 4 e to the y plus 4x e to the y dy dx. Okay, I am not going to simplify this, but that could be done, I guess, over all of this squared plus 4x e to the y squared. Okay, I write these problems and sometimes I don't think a whole lot about them before I write them, but it was still doable and it got done. Let's try something that'll hopefully be a little bit easier. Find all equations of the tangent lines when x equals 5 of 5y to the 4th equals xy minus 5 plus x. Okay, tangent lines. So we need to find the derivative to find the slope of the tangent line. So we have 20 y to the 3rd equals y plus, this is once again product rule, dy dx plus 1. And look, I did something that you are likely to do. I forgot a dy dx. So we'll move the x dy dx over and then factor it out. So 20 y to the 3rd dy dx minus x dy dx is equal to y plus 1. Factored out, dy dx is equal to 20y cubed minus x equal to y plus 1. So we'll divide. Dy dx is equal to y plus 1 over 20y cubed minus x. Okay, so if we plug in x equals 5, we'll see that we still need a y value. And so what we can do is we should actually plug in 5 here first. So we have 5y to the 4th is equal to 5y minus 5 plus 5. That will cancel. And we have, be careful here. It's important for us to not lose one of our zeros here. What I mean by that, if we were to divide by 5y, we would have y to the 3rd is equal to 0. And we might end up losing a 0. So I'm going to instead factor the 5y out. So we have y to the 3rd minus 1 is equal to 0. So y is equal to 0 or 1. Y to the 3rd minus 1 equals 0. Y could be 1. Okay, so we need to plug in 2 different points. We need to plug in 5, 0 and 5, 1. Okay, so let's go down and work on our tangent lines. So if we first plug in 5, 0, we get dy dx, 5, 0. We have 0 plus 1 over 20 times 0 minus 5, so negative 1/5. And our equation is y minus y1, which is 0, times, or is equal to the slope, negative 1/5, x minus 5. So there's one of our lines. And the other one would be 5, 1 would be dy dx is equal to 2, 1 plus 1 over 1 cubed is 1. So 20 minus 5 is 2 over 15. So we have y minus 1 is equal to 2 over 15, x minus 5. Okay, so an important topic, a lot to do. These can be long problems, like you saw, especially because there was a lot of product rule and even quotient rule. I hope this helped you understand how to do implicit differentiation, and I'll see you in the next video.